Hello everyone, welcome to the next class. So we were discussing the previous year gate questions from the subject signal system from topic Fourier series and Fourier transform. So this is the next question from GATE EC 2017 paper set 2. So questions is that consider an LTI system with magnitude response which is given to us, that is HF is equals to 1 minus F by 20, where F is less than equal to 20 and 0 otherwise. And also phase is given here. Phase is HF is equals to minus of 2 into F. Input of the system is given, which is equals to xt, and what you have to find out the average power of the output of the signal. So what is this? So some LTI system with response HF is given to you, right? Some input xt which is given to us is given to this LTI system, and output yt is obtained, and you have to find out the power of this yt. So how to proceed with this? In order to proceed with this, you should know that what this filter is actually doing, what this system, LTI system is actually doing. So this LTI system is defined like this. So it's nothing but a triangular waveform output, or you can write it is a triangular waveform equation. So you can say that this is a having slope of negative, one is the intercept, so one is intercept having slope negative first, and from minus 20, for positive slope it will be 20. So this is HF is given here, right? This is F. Now knowing that this is the waveform, or this is the response HF, we can pass xt signal through this in order to obtain yt, right? And for we have to find out the power of yt. Now this is in frequency domain, these xt is given in time domain. So what's the thing, next thing we have to do is to convert this xt into frequency domain, so we can see that what frequency passes through this filter HF. Now the signal xt is given like this: 8 of cos 20 pi t plus pi by 4 plus 16 sine 40 pi t plus pi by 8 plus 24 cos 80 pi t plus pi by 16. Now x of f we have to write. Now this is cosine signal. The Fourier transform of sine and cosine are nothing but impulses. So if I write cos 2 pi ft, so Fourier transform of this signal is 1 by 2 delta f plus this f naught. Let me write it here only. F plus f naught plus delta f minus f naught. Similarly, for sine 2 pi f naught t, the Fourier transform is 1 by 2j. Now j does not change in the magnitude at all, it just changes in the phase, right? J is minus 90 phase shift. 1 by j is minus 90 phase shift, and j is 90 phase shift. So it is f minus delta f minus f naught. So these are the Fourier transforms of cos and sine. So we will know that cos and sines are nothing but two impulses. So Fourier transform of cos is also two impulses, Fourier transform of sine is also two impulses. So let's just see. So for this first function, second function, and third function, we have to write out the Fourier transforms. So it will become 8 by 2, that will be 4 delta 20 is here, f naught frequency, the fundamental frequency here is equals to 10. Here it is, because it is 40 pi t, so f naught will come out to be 20. Here it will come out to be 40. So we can write it easily: f minus 10, or let's just start with this, f plus 10 delta f minus 10 plus 16 by 2 is 8 sine, or you can write it j also here, sine 40, that will be f minus 20, you can say f plus 20 minus delta f minus 20. This is deltas, delta and delta. Similarly, for the last one, we can also write, there is no space here, so I'm just writing it here only. So 24 will become 12 delta f plus 40 plus delta f minus 40. So these are the Fourier transforms. Now these are the impulses. Now we have to check that if this impulse passed through this filter or not. Of course, this is coming here plus 10 and minus 10. So this both the impulses will pass. Now this 20 and minus 20. It is ending at 20, right? So it is becoming 0 at 20. So they both will not pass, and 40 is of course equals to 0. So they will also not pass. So only this function will pass. We can easily see it directly without even calculating here, and that is the shortest method. Without even calculating this, we can see this f naught. We have already calculated f naught. Here f naught was 20, here f naught was 40. So f naught 10, yeah, of course it will pass. F naught 20, it is coming out to be 0, it will not pass. So this signal will not pass. It is f naught is equals to 40, so 40 will come right here, so they will also not pass. So only this particular signal is passing through the filter. Right. So there was even no need to calculate this, but I was showing it to you so that you understand that what's actually going on if some students are doing it for the first time. Right. So in this particular question, there was no need to find out the XF. We should know that if this will pass or not by simply looking at their fundamental frequencies, because we know that the Fourier transforms of cos and sines are shifted version of their fundamental frequencies, shifted impulses. Right, so I can say that only so only yt you can write, only a first wave will pass, so yt will become equal to 4 of cos, it will be divided by 2 only, so 4 of cos 20 pi t plus some phase that will be there. It will of course change because there will is some argument, because of argument given to us, right? That will be equal to pi by 4 minus 20 degrees. Now, phase is not at all important because we have to find out the power. So power will be what? Power is always dependent on the magnitude. So power of any sine and cosine signal is equals to amplitude square by 2. So power is equals to amplitude, that is 4 square by 2. So power come out to be 8 watt. So this is your final answer. So it was very easy. You just have to understand that what is this, that how to write this into equation, or you can understand what type of function this is given. So this is a triangular waveform, right, having intercept 1 from minus 20 to 20, otherwise it's 0, right? Next is this, you have to just find out the fundamental frequencies, and you saw that this will not pass, this will not pass, only this will pass, so this will become your output. So output is this. So in output we have write, instead of xf, so you can say that YF was equals to 4 of delta F plus F naught. F naught here is 10 plus delta F minus F naught. You can again do the conversion, right? So the conversion will be cos 20 pi t plus some phase. So that is your conversion. So by this conversion, you can see that only this first signal will pass and these two will not pass. From this, you can easily calculate the power, because power of any sine and cosine signal is nothing but amplitude square by 2. Right. Moving on to the next question. A continuous time signal xt is equals to 4 cos 200 pi t plus 8 cos 400 pi t, where t is in second, is the input to the linear time invariant filter, which with the impulse response which is given to us. Let yt be the output of this filter. We have to find out the maximum value of yt. Very similar type of question like previous one. So here ht is given. So impulse response of a filter is given. Input is xt, which is also given. We have to find out yt, maximum value of yt. right? So again, we have to plot the filter in order to find out that which of the function, which of the signal from the xt is passing through it and which is blocked by this type of filter. Now we see ht here. Ht is 2 sine 300 pi t divided by pi t. It is a sync waveform. So if we want to convert sync into its frequency domain, so it is nothing but a rectangular waveform which we have already seen. So in general, sine at by pi t, if I do the Fourier transform of this signal, so it is equals to rectangular function from the, this is magnitude 1, because this is magnitude 1. So it's x omega minus plus omega minus omega. It lies from minus a to a. So this is how we convert sync at by pi t into its frequency domain. Similarly, we can convert this also. So what will this become? So h of f, here the magnitude is 2. So magnitude 2 omega. So this is from minus 300 pi to 300 pi will be the range. Right, it is from minus a to a in general. So here a is equals to 300 pi, so it will lie from minus 300 pi to 300 pi. So now you see there are two functions in this. So this is signal 1. So here omega 1 is equals to 200 pi and here omega 2 is equals to 400 pi. Now which one will pass? So omega is limited from minus 300 to 300 pi. So this one will pass, of course, it will come somewhere here. But this will come somewhere here. So this will be rejected by the filter. Only this will pass. So only 4 cos 200 pi t will pass. Now filter is also doing what? The magnitude it's multiplying with 2. So yt will be equal to 2 into 4 cos of 200 pi t. So it will be equal to 8 cos 200 pi t. So what's the maximum value yt? If you find out the maximum value yt is nothing but 8. So 8 is your solution. So this is how we can solve this type of question very easily. So whenever this ht is given or hf is given in a function, so we can always convert into a waveform so that we can check that which of the frequency will pass and which will be blocked by that particular filter, right? Okay, see you in next class.